plus 3w. So 2 times vector v plus 3 times vector w, 2 times the vector plus 3 times the vector, and we just multiply it inside first. And then just combine component wise. The first two give us 16, negative 28, negative 21. Yeah. And we can just give the answer in this angular bracket notation. Right. Next, let's go back. 28. So the unit vector in direction of v, so that will be that. So we will take this vector here, 12 and 5, over the magnitude. So still 12 and 5. The magnitude will be 13. And then we can just split. And will be just that. Yeah. So that is the unit vector in the direction of another vector. Yeah, we do need to know that. Right. Next, let's do a dot product. So dot product. So we just multiply. Oh wait. Yeah. So multiply the first with the first, add to the second with the second, and then the last with the last. So we have 3, 2, negative 6, and that's negative 1. Dot product is just a number, so that's easy. Right. The angle between two vectors, we do have that formula. So we have that. So cosine of theta is equal to the dot product over the magnitude of the product of the magnitude. So vector u is ij, so it will be just 1 for I, 1 for j, nothing for k. W 1, 1, negative 1. Over the magnitude of u, 1 square, 1 square, 0 square, 1 square, 1 square, negative 1 square. And the dot product gives us 1 times 1, 1 times 1, 0 times negative 1, and here we have square root of 2, square root of 3. So do all of that, we have cosine of theta will be 2 over square root of 6, and with that cosine inverse of 2 over square root of 6. Have 35.26 degrees. Yes, that. Right. So that is the dot product. Right. Next we'll go to a cross product. Cross product pretty much we have again the formula, those formulas you need to know that. So wait, dot product we did 34 and 35. Cross product 36 is straightforward, so we'll just do that. I'm doing 37 because we have one of the properties of the cross product is that the cross product is orthogonal to both of the vectors. So pretty much we find the cross product here. So V cross W I J K -5, -3, 1, 2, -5, and -1. So first, cover the row and column that we have for vector I, for negative vector J, and then for vector K. Right, for I we have to cover that up. Then J, and then K. Right, and now we just need to do that. -3 plus 5. I'm sorry, that is +3 plus 5, so that will be 8. +5 minus 2 is 3, but with the minus. And then 25 and 6, 31. Okay. So pretty much that. So the cross product is orthogonal to both. We can also do W cross V or V cross W here. It doesn't matter. Right. Next, area of parallelograms. So kind of have sketched real quick like that. So do the 5P1, P2, P1, P2, the vector is the point P2 minus P1. So it will be -3, 6, and 5. Actually, we have one vector here. So we do have the formula for that. Yeah, that. We do need to have the adjacent side, so we do need to have this. So P1, P4, which is P4 minus P1, P4, 0, 3, 13, minus P1, so negative 7, positive 8, and positive 8. Right, and then we just do the cross product of these two, just the cross product. And at the end we will find the magnitude later. So I, J, K, negative 3, 6, 5, negative 7, 8, 8. Right. So I'll skip a few steps here. So 48, 48 minus 40, so that is 8i. The middle one, negative. Negative 24 and plus 35. Just do this. Negative 24 plus 35. 35 minus 24, so that's 11. J. And then plus negative 24, 24 and 42. Be 66. Sorry, 42 minus 42 minus 24, that is 18, 18k. Right. And then we find the magnitude of that. A square, negative 11 square, 18 square. It's 509. So it's that. Yeah. So we need to find P1, P2, just the two adjacent sign, and then do the cross product. And need to take the magnitude, because the cross product is a vector. We need to find the magnitude of it, which is a number. Right. Next we go to. Let me update the list. Right. Parabolas. Where is that? Right. So the formula will be over there. Right. The problem, we need to know where's the vertex, where the focus. The focus is not on the graph. The vertex is on the graph. So let's just try to plot them. So doing 39 here. The vertex is 4 and 3. And the focus is 7 and 3. I mean this. So 4 and 3, 7 and 3. So this will be the focus. Next, since the graph will go through the vertex and around the focus, so it will be like this. Just get a sketch. So kind of like that. This is a parabola that open to the right horizontally, so we will have the form x minus h squared equal to 4a y minus k. Sorry, y minus k squared equal to 4a x minus h. Right. It's open to the right. So look at the first one here. Right. Now we know put h and k here, so we have y, which is h, that is k. And then a is the distance between the vertex and the focus. If it open to the right, it's going to be positive. So we have, this is distance 3, so we have y minus 3 squared equal to 4 times 3 x minus 4, which is y minus 3 squared 12 x minus 4. Right. We do need to sketch to get the idea of what the graph of the function look like. Right. Do 40 as well. Next, 8 and negative 3 and 8 and negative 5. So we have the vertex here, the focus here. The graph always go through the vertex and always go around the focus. And the distance here we do know is 2. Right. This is the parabola that will open down, up and down parabola. We start with x. In this case, h and k, we have x minus h squared equal to 4a y minus negative 3 x minus a squared, 4a is 2. Right. Of course, we need to do one more thing, and that one more thing is, if this one open down, it will be negative. Yeah, just using red. It's open down, it is negative. And a is always positive. So x minus a squared equal to negative 8 y plus 3. Right. So I have to kind of sketch the graph and see where the parabola opens up. I mean, where's the direction of the parabola or opening, and then we can determine if it is something x squared minus y squared minus x squared, and if it is positive or negative. Right. Next we will find the vertex, the focus, the directrix, and then try to graph the parabola. Right, so on this one we know we have y minus 4, x minus 3, so x equal to 3, y equal to 4. That is the vertex. Right. And this, when we have a positive and y squared x, so that is the parabola that open to the right because it's positive. So we just can sketch like that. Because it open to the right positive, we have y squared, so that definitely horizontal and open to the right. Next we know that it is like that. This have to be equal to 4a. So in this case a is equal to 3. So if we go 3 units to the right, that will be the focus, and 3 units to the left. That will be the directrix. So we have directrix is y equal to 0. Sorry, x equal to 0. Sorry, that is the vertical line, so x equal to 0. I should write the y-axis, or x equal to 0. And then the focus, where the graph goes around it, we have y is still equal to 4, and x is 3, 4, 5, 6, 6 and 4. Right, so kind of have to know the relation between this, the graph, and the equation. Right, talk about equation. This one did not give us directly, but what we can do is this. First, we do the completeness square. We will add something to it on both sides. And that something is going to be half whatever that is, and then we square. Half of that is 4, and we squared will be 16, and we add on both sides. The left side will be equal to ay minus 40, and the right side will have a square that has 4 in it, and then will be just x and the minus sign. So if that is the equation, and then we can just find the rest of the information. So if we write like this, we have the equation, and the rest should be simple. Right. So that is the problem. So once again, we need to know the vertex, the focus, and the directrix. Either that, the equation, and how they related. Again, the graph we open always go around the focus, and we go through the vertex. Right. So for parabola, we did 39 to 41. Now we go to ellipse. Sorry, we to reply to text real quick. Right. Next we have ellipse. Right. Of course, the formula is there. Right. So for ellipse, with different things. So first, for this equation, we have the equation already. We know that x minus 2 and y plus 1. From here we have h is equal to 2 and k equal to -1. So the center will be at 2 and -1, 2 and -1. Right. Next, we will take the square root of this number, square root of that number. It's pretty much 3 and 4. It doesn't matter which one is A, which one is B. It's not really important. What we need to know is that the 4 is below the x, meaning that from the vertex we go 4 units to the left and 4 units to the right. Also 3 units up and 3 units down. So we draw a box. I'm sorry, the box. Like that. And the ellipse will fit inside that box. Right. Right, so we have the ellipse. That's easy. Now we need to find the focus, the foci, two of them. So this one is kind of horizontal. When we draw that, we see, we know that the foci is somewhere in here and somewhere in there. And the distance from the center to the foci is always equal to c. Right. Now whether, of course, we have the formula b squared plus c squared is a squared. That's not really important. What we see here is the biggest side is going to be 4. So Pythagorean theorem, we have 4 squared by itself. The other side we don't know. 2 smaller signs will be c, and then b, which is 3 squared. And do this, we have c squared equal to 16 minus 9 will be 7. So c is plus or minus square root of 7. Right. And finally, from the center, we go to the foci. That is what we have for the center. Since this one is horizontal, so we need to do, we're just going to put this next to the x-coordinate of the first foci, and that's all we have. So it's very important in hyperbola and ellipse, we have to know where the box is, and then we find a, b, or c. Notice in this case, a, whatever that is the biggest number. 4 is the biggest one out of all of this. So I put 4 square by itself. The other 2 square will be on the other side. We mentioned this in class. Alright, so that is 43. Kind of similar on this one, but remember the standard form. We have to divide by something. To have 1, so in that case we have to divide by 324. And whatever that is, because I'll let you figure that part out. Okay, now we graph. First in this graph we have the foci is -4 and 1. And -4 and -5. Right, those are the two foci. And the center must be right in the middle. The middle of those two. So look like will be -4 and -2. So first thing we have is the center. So try to put things together. We will have the form for the ellipse will be x minus -4 square over something square, y minus -2 square over something square equal to 1. So we have that already. Next, the length of the major axis. The major axis here is 10, and look like this is going to be the vertical ellipse. So the major axis is going to be this, and this is 10, meaning we have 5 each. So it will be 1 point here and 1 point there. So the ellipse will go like this. The only thing need to determine is what is the width on that side of the ellipse. So that be b, So in this ellipse, we have 5 is the biggest distance, so we're going to put 5 squared by itself. And then we have b squared, which is smaller, and then c squared, which is 3. So from here we have b squared equal to 16, so b is plus or minus 4. Right. Finally, we have b is 4. By the way, the b will go in the x direction, so I have 4 squared here, and the bigger one on the y direction, 5 squared. Yeah. So like I said, it doesn't which one go first. Just the bigger one will be with the direction of the ellipse. In this case, we know that since the foci align vertically, it's going to be vertical ellipse, and the vertical ellipse have the bigger numbers here, and that is the major axis. And that's what we have. Right. 45, and now 46. First we have the focus, the foci 1 and 5, and negative 7 and 5. Again, the center will be right in the middle. I keep doing that. 1 and 5 and negative 7 and 5. Sorry. So those are the foci. The center must be in the middle. Let's just count. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 1, 2, 3, 4. So be right here. So the center negative 3 and 5. Right. So I will start with x minus 3 square and y minus 5 square over something square equal to 1. Right. We know one of the vertex is negative 8 and 5. So the vertex is here. And because of that, that distance will be equal to 5, which is the biggest one. So the ellipse will go around. Like that. The biggest distance is 5 square, so I'm going to put 5 square by itself. The smaller distance, first we have the foci to the center, that is 4. And then whatever we need is b square. So b square equal to 9, so b is plus or minus 3. Right, so we have that. Doesn't matter which one's b, which one's 8. We do know that it goes left and right 5 units. Left and right 5 units, so I have to be this. And go up and down 3 units, so I have to be that. Yeah. So try to tie the graph with the information of the ellipse. Pretty much for anything, we should be able to see the graph before we try to come up with the equation or come up with the information of the conic section. So we have 43 and then 46. Right, a problem. Also, we do need to have the box. So first, let's plot this. Wait, note that. Again, formula on that side. The center is 7 and 6. 7 and 6. The focus 1 and 6. 1 and 6. And then a vertex 6 and 6. So the vertex is here, the focus is there. So look like it go horizontally. So the graph, we don't know yet, but it will go like open that and the other direction. Right. That to be determined. Right. What we do know here is the center. So from there, we know it's open horizontally. Horizontally meaning x have to go first. Again, h and k. So x minus 7 square minus y minus 6 square equal to 1. So we start with that already. Now, on the x direction, we need to find the box. So the box is where we go from this to the vertex. So this is just one unit to the left. So one left, one right. So we just that. Next, we need to find whatever it is. So we have the box like this. So the box, we know the smallest distance is 1 square. Again, I don't bother to write a square, b square, so we have 1 square. The biggest one here will be the distance from the four sides to the center. So that will be 6 square by itself. The other one, I will be just find out whatever this is. Let's use b then, doesn't matter. So b square equal to 36 minus 1 to 35. So b is plus or minus square root of 35. Or we have 35 here. Sorry. So x minus 7 square over 1 minus y minus 6 square over 35 equal to 1. So if we want to graph it exactly, first we have the center. We go one left, one right, and then square root of 35 up, and square root of 35 down. So we kind of have the box like this. Next we will have draw the diagonal for the asymptotes. And the ellipse will be just with asymptote and touching the vertex and go around like that. And this is the transverse axis. Right, so that is 47. 48. Okay, we have the equation, so that's different. Right, so first of all, x minus 1, y plus 2. So from here, right away, we will get the center. H and k, 1 and negative 2. So center 1 and negative 2. Next, this one we go 4. Again, we take the square root, meaning that we go 2 units left and right. 2 units on the left, 2 units on the right. 6 units up, 2, 4, 6, and 2, 4, 6, and we will have a box. And asymptotes. And this one, this one we start with x, so again it will open left and right before we start with x. Right, so that is what is the hyperbola look like. Right, so we have the center. Right, we know that the distance here we go 6 units up and then 2 units to the right. The foci will have to be somewhere here and there. The distance to the foci will be the biggest one, so I put that by itself. On the other side we will have 2 square and 6 square, so that will be 40. C square is 40, so C is plus or minus square root of 40. With that we will put in the foci like this. Originally we have the point for the center, and then since the foci go left and right, we're going to just put that, and we have the foci. Right. Next, the transverse axis is going to be this. So we say this is going to be y equal to -2 is the transverse axis. Right. Next we have the foci. We have vertices. Vertices, the distance we go 2 units to the left, 2 units to the right. Again, everything will base off the center. And since we go 2 left and 2 right, we're just going to have that. Yeah. As you see, it's just a function of the center. We're just adding C to it to have the vertices, and add C to it to have the foci, and minus a number wherever the distance we go, we get the vertices. And that's pretty much it for this one. Right, sorry, we still need to find the asymptotes. Asymptotes equation will be y equals mx plus b, so y we need to minus the center, so pretty much like this. And then the slope rise over run, positive or negative, so pretty much that equation. So the asymptotes are this: y plus 2 equal to plus or minus 3 x minus 1. So the center is very important. As you see, the center appears in all of this. The foci left and right C unit in this case because it is horizontal, and the vertices left and right also, whatever the distance that we go. Okay. Of course, when we write like that, it looks silly. It looks like -1 and -2 and -3 and 3 and -2. Right. So everything is a function of the center. Add something to it, or the slope determined by rise over run. So that is 48. I'll just finish with 49. So on this one, first the center, as always, center x 2 unit to the right, 2 and -1, that is h and k. Which is here, 2 to the right and 1 down. So that is the center. And then we take the square root of this. So we have 3 units on the y direction, meaning up and down. 1, 2, 3 up, 1, 2, 3 down. Right here. 1, 1, 2, 3. There. and then on the y direction, on the x direction, 5 left and 5 left and 5 right. We will make a basic box, and we have the asymptotes, which will be the diagonal. And finally, this one with the y subtracting the x, meaning that it have to be all vertically. So we go to the vertex and approaching to the asymptotes. So that's what we have. Right. With that, we cover everything. And on the last 3 topics of the conic sections, we always have to go with the graph. Everything will base off the center for the ellipse and hyperbola. And for the parabola, we do not have the center, we only have the vertex. So everything will base on the vertex for the parabola. And after that, we have to know the relation between the graph and all the information of the conic section. Alright, so pretty much that cover everything. Will be on the test 3. I hope it helped you to prepare for test 3. Hello everybody, welcome to test 4 review. We really don't have a test 4, but this will cover pretty much everything between test 3 and the final. As always, the formula on that side and the topics that we cover be on the top. Right. So first, classify conics. Sorry, there was something going on. Somebody called me in the middle, so I have to stop the video in the middle while I already have this stuff down. Anyway, so to classify conics, the equation like this, only the coefficient for x squared, xy, and y squared are important, and we find the discriminant. Remember that. Notice that d is not really this d, so that's confusing. So let's change that to delta. And if it is less than 0, ellipse equal to 0, parabola. Hyperbola will be greater than 0. Hyper meaning is greater than 0. I mean that makes sense. Anyway, so a equal to 1 or the first one, b equal to 10 and c equal to 25. Put in the formula. That equal to 0 is parabola. Same thing on the next one. So b squared minus 4ac, and we have that. Less than 0, so that ellipse. So yeah, just change that to something else other than d, because that will be redundant with the formula here. Right. Next, we really don't have this in that topic, but I'm going to do that anyway. So first, what we look at this, we see 2 and 2 and 2. So why don't we divide 2 on the top and bottom? So when we do that, we have r equal to 1 over 1 minus cosine theta. Right, cross multiply here. We should have r 1 minus cosine theta equal to 1. Now, multiply it out, we have r minus r cosine theta equal to 1. The objective here, because we're going to turn that into a rectangular equation, so pretty much these are the formula we can use. X is r cosine theta, y is r sine theta, and x squared plus y squared equal to r squared. So here we have r cosine theta, so that will be x. So we have r minus x equal to 1. Right, now next is a tricky part. We're going to somehow turn the r into x and y. The only thing we can do is r squared is equal to x squared plus y squared. So we're going to add x on this side. So we have r equal to x plus 1. So I will add 1 on both sides. I mean add x on both sides. Sorry. And after that, I can square both sides. And square will be x squared plus 2x plus 1. Right? And move the x squared over. But first, all we can use x squared is r squared is x squared plus y squared. And we cancel that on both sides. Yeah. The second problem will be kind of like that, but let's omit it. Right. So when we change to rectangular equation, we can use that. Right. Next, on the final, we might have something like that when we change to rectangular equation, but not this complicated. Right, next we go to rectangular from parametric equation. So we have this. So what we see is we either solve for t we can solve for t for either x or y, it doesn't matter. So I probably will solve for x, because when you substitute in here you have y equal to something. That will be better. So if x equal to 3t, all we need to do is divide everything by 3, and we'll have t equal to right. And we substitute t equal to x over 3 into this. So we'll just have y equal to t plus 3 will be y equal to x over 3 plus 3. So that's pretty simple there. The only thing we need to worry about is this. So let's write that again. So that's what we have. Now, in order to have t is equal to x over 3, so I will substitute x over 3 like that, and multiply everything by 3. And I will have x between 9 and negative 6. Right. So that's what we have. So yeah, we either solve for t from x or for y, and then substitute into the other equation, and finally try to find the range for that as well. Right. Next, this is completely different, because if we solve for t, it will involve the inverse, and substitute in it, that will be a mess. So instead of that, what we do is I will divide by 4 on both sides here. And I'll do the same thing for the other equation. Right, doesn't help much. However, if we square both sides, we have x squared over 4 squared, y squared over 4 squared, square, of course. And then if we add side by side, x squared over 4 squared plus y squared over 4 squared equal to 1. This is an ellipse, or more specifically, it is a circle. So we just multiply 4 squared on both sides, or we have x squared plus y squared equal to 16 if we multiply 16 on both sides. Right, and t go from 0 to 2 pi, so this will complete one revolution. So all we have, can multiply by 16 to get that. It doesn't matter. Right, so if we draw an ellipse, would be 4 up, 4 down, 4 left, 4 right. So that's pretty much just a circle. So for that circle, we can say x is between -4 and 4, and so is y. So the parametric equation usually will go with the domain for the variable. So we should have the domain for either x or y. Right, so that's the question. Right, so usually when we have sine, cosine, the only way to eliminate the parameter t, the best way is to somehow get the sine, cosine by itself, square them, and add them. We eliminate the t. That way will be the most efficient. Right. Now we have the other way around. When we have the parametric equation, and now we have the equation like this, and then we turn to parametric equation. So this will be, for that one is easy. For this one, not so much. For this one, if we let x equal to t, then y equal to 2t minus 5. This is almost still easy, because when x equal to t, and that's 2t minus 5, just like that. The only thing we need to specify is the domain for t. So since we do not have anything here, we just say t is any numbers, so we should say that. Yeah, because there's no restriction for x and y, so it should be that. Alright, next, parametric equation that move along the ellipse. I try to sketch this ellipse. 8 unit left and right, and 9 unit up and down. So this 8 and 9, and ellipse go like this. And we go from a and 0, 8, and go clockwise. Right. Actually, let's ignore this condition. Just assume that somehow we get the ellipse. That would be fine. So it will get very complicated later. So for now, we have x squared over 64 plus y squared 81 equal to 1. Yeah. So kind of like this. We know that somehow we have to turn to compare that to cosine square and sine square equal to 1. If we have the condition here, that could be tricky. But let us assume that let it know that condition. In that case, it will be a lot easier. Then we just say one of them is cosine and one of them is sine. We can mismatch if we want to. But let's say x squared over 64 is equal to cosine square. So taking the square root on both sides, we have x over 8 equal to cosine theta. So multiply by 8, x equal a cosine theta. Y squared over 81 equal to sine square. I will take the square root as well. We have y over 9 equal to sine theta. So y equal to 9 sine theta. Alright, so we have x and y. If we did not specify the speed, how fast it go around, and that would be easy. We can just generically say go from 0 to 2 pi, or we can go more than 0 to 2 pi if we want to go around it many times. But generically, we can just say from 0 to 2 pi. Yeah, if we do have that condition, then we might not have enough space to do that problem here. All right. So next we have partial fraction. So for this we should have the calculator, because there will be a lot of system of equation. I'm going to put the calculator there. Alright, so first problem. Now we have two factors here. Two factors there. So we will have a factor of x minus 2 and then x minus 4. On the top we have less degree than the bottom, so we have a and b. Right. Multiply both sides by the common denominator. That we will have x minus 12 equal to a x minus 4 plus b x minus 2. Multiply it out. Ax minus 4a plus bx minus 2b, and then group the coefficients ax, bx. We have a plus b where we factor out an x, and this right. So like that. Next, what we do is we just match the coefficient, meaning that this one go with x must match with this. The coefficient must be the same. Therefore, a plus b must be equal to 1. And then that coefficient must be equal to this coefficient. So the same power terms we have the same coefficient. That is what we call the undetermined coefficient. Right, now we'll go to this. Right, great. This calculator doesn't have that app, so I have to switch to my own calculator. Right. So I go to apps, look for we can also solve using matrix, but I do this. So go again, polynomial. I will go back to that later. So simultaneous equation. Right. This we have two variables and two unknowns. So we have two equations, two unknowns. Just give a fraction and go next. The coefficient is 1 for A, 1B, 1, and -4 for A, -2 for B, and -12. When we solve, we have 5 and -4. Alright, so let's go back to that app again. Alright, it will be in polynomial simultaneous equation. Right, that one. Polynomial root finder. Sorry, not that. The second option, simultaneous equation. Right, so, and we just keep doing that. Right, now since A is 5 and B is -4, we put it back into this form. We have 5 over x minus 2 plus -4 over x minus 4. That is the partial fraction. Right. I will do a lot more of this, of course. Right, so that was 10. Right. Now the idea of this, if we just have the linear factors, then on the top the power have to be less than that, meaning that we do not have any x on the top. So be just like that. Multiply by the common denominator, combine like terms, and then matching the coefficient. So will be like what we just did. Next, we go to 12 instead. Right, for 12. The difference in this problem is that we have the x plus 1 square, meaning that we have the repeated factor. If it is repeated, we have to increase the power from 1 to 2. If this is a cube, we're going to have one more, x plus 1 cube, and then higher power. We just go from first power, second power, third power until we match that power. Now that is A, over here just B, and even though this has the square, will be just have the same form as this, so will be just C and not Cx plus B, just C. Right. And then the same way, multiply by the common denominators. I will speed up on this one. So we have that. Right. We have a 1 of x plus 2. We will have x plus 1 and x plus 2. We have x plus 1 already, so we will have x plus 2 square and x plus 2 square cancel. Right. Multiply it out. I'll skip a few steps here. Alright, and then multiply it out. Right, combine like terms. X square, that's it. Now the x. Three A, 4B, and a C for x. And then 2A, 4B, and C. And that must be equal to the left hand side of negative 4x squared minus 14x minus 15. Right. So now we just match the coefficient. Match for x squared with that, meaning a plus b must be negative 4. Negative 14x must be equal to this. So 3a, 4b, and c is negative 14. And the last one equal to negative 15 is this. Right. Now back to the calculator. So we go to that screen. This time 3 equation, 3 unknown. Right, now the coefficient. Right. We have 1 for A, 1 for B, no C, negative 4. Notice negative is this negative sign and not that subtract. And then 3, 4, 1, negative 14, 2, 4, 1, negative 15, and then so. Right. X is 1. X of course is 8, so we have A is 1, sorry, B is negative 5, and C 3. So put it back into a original equation. We have 1 over x plus 2, negative 5 over x plus 1, and 3 over x plus 1 squared. Right. For some reason Go back to the coefficient. I apologize, this should be x plus 1. Yeah, I should not rush this one. Wait. Yeah, I got them backward. Sorry. Let me try this again. Right. Let's do this instead. We will multiply x plus 2, x plus 1 square. In that case, we will not miss anything. X plus 2, x plus 1 square. Right, much better. The whole thing cancel here. Yes, I should do that at the first place. So x plus 2 cancel. One of the x plus 1 cancel. Sorry, this was a square. Right, so right. So that one and that was a square. So the square cancel. We just see an x plus 2. Right. Now multiply it out. Right. Multiply it out. Right. Combine like terms. This is square. That is the square. For the x's, 2ax, 3bx, and cx. And then we have a and 2c and 2b, of course. Right, so we match AB, we match with 4x squared, negative 14x. We match that with this, and the negative 15. we match with that. So let's write the equation. A plus B, or some space, right. Back to this system of equation, we have 1, 1, negative 4, 2, 3, 1, negative 14, 1, 2, 2, negative 15, negative 3, negative 1, and negative 5. Right. Sorry about that. We should have just multiplied the least common denominator like this and cancel what is missing. I should not speed up that step. So A is negative 3, B is negative 1, and C is x plus 1 squared. So yeah, so just multiply to the least common denominator and cancel what is missing. We should have that. Also note when we have the repeated factor, then we just have that and then that factor square, and then if we have more like the cube, then we will have one more for cube. Right. Right. Next, we have this with a quadratic factor. So it only have two factors, so it makes sense if we just have this. Now, on the top, the power on the top must be less than the bottom. This bottom have only x, so the top have no x. This bottom is x squared, so the top will have one power less. We cannot have more or equal power of x on the top than the bottom. Right. Now the least common denominator is this. Now we just do like we did last time. It's better just be careful with this common denominator. Right. That cancel. This cancel. And the whole thing cancel. So we have that. And then we'll just multiply it out. Combine like terms. Except, sorry, this problem we have A already. This should be different coefficient. So instead of A and B, so let's change it to D and C. All the coefficients must be different. Right. At least this one we haven't gone very far. So it should be B and C. Sorry about that. So all the coefficients must be different. Right. Now we multiply it out. Ax squared plus ax plus a, and then bx times x, bx squared, bx times 1 negative bx plus cx minus c. Right. Combine like terms. Ax squared and bx squared. We have x squared ax negative bx and cx. So a minus b and c x. And finally, for constant, we have a and negative c. Now we just match a coefficient a plus b. Since there's no x squared here, we're going to put 0x squared and make that equal to 0. A minus b plus c equal to 10, and a minus c equal to 2. Right. Right. The coefficient 1 for a, 1 for b, 0 for c, and 0 there. 1, negative 1, 1, and 10, 1, 0, negative 1, and 2. Right, we have 4, negative 4, and 2. And put it back into this form, we will have 4 over x minus 1 plus negative 4x plus 2 over x squared plus x plus 1. Right. This problem I will not do it, but I at least will give the form. We have the x squared plus 5, but repeat it. Since this is square, so we have 2 of them. We're going to have 2 of them. One with the first, one with the second, because we only have 2 of them. On the top, we just put ax plus b, and then this